Okay, so today we are doing Unit 7 still, filling and wrapping. We are doing scaling up prisms. So this is a bit tricky. It does deal with exponential ideas, but it won't be as complicated as it sounds. So 1.4, scaling up prisms. Sorry, these dates are a little bit off. Today is March 4th, no, 5th, 6th. Today is the 6th, March 6th. There you go. All right, so here is your um, title and your focus question, and we are not on page 54. Um, so how as you change the dimensions of a rectangular prism by a certain scale factor, how do the surface area and volume of that prism change? So one, you have to remember what scale factor is. If you don't know what scale factor is, we'll talk about it a little bit more. There's a definition at the bottom of these notes. It is important to know. Now, as something increases, how do the surface area and volume increase? So we have to be able to calculate the surface area. We have to be able to calculate the volume. And we're going to compare scale factor to surface area and volume. Very important ideas. So this lab sheet you picked up on the way in should be in the basket by the door. Cut and glue this into your notebook. We'll fill this in together a little bit later. Here are a few of the ideas and definitions you need. So scale factor, as a reminder, the amount a single length, width, or height value is increased. So for example, if I have a length that's increased from 2 inches to 4 inches, my scale factor is the new value 4 divided by 2. So the new one divided by the old one. That's my scale factor. That's how much it changes. Now, scale factor can also decrease. In this lesson, we're only going to be increasing our scale factors. Area factor. Area factor is the amount the area is affected by the scale factor. So this one was changing a single length to a, so scale factor is a single length that's increased. So how much did it increase? So here it doubled. Area factor is a little bit different. If I have a square that's this big, and then I double every side, so let's say my new lengths double, so instead of it being this long, it's this long, and this side is this wide. How does the area change? Well, the area is not doubled because it actually gets 4 times larger. Okay. In this case, we doubled it, so it becomes 4 times. If I tripled it, it would be 9 times. So it's my scale factor squared. So in this case, it's scale factor of 2, so it's 2 squared. If it was a triple value, then it'd be 3 squared or 4 squared, etc. Okay, that's a bit tricky because instead of increasing a single value, I increase 2 of them. So I increase the length and the width. Okay, so I have to increase by more than just one value. Okay, go ahead and pause the videos as you need to write all this down. This is important. I know it's a little bit wordy, but it should be in there. Take your time, especially for those of you who do not have nice handwriting. I need to be able to read this. You need to be able to read this. Okay. So if I had a original size of 2 inches to 4 inches, sorry, 2 inches to 4 inches, so the length and the width went from 2, 2 to 4, 4, my area doesn't double. It's not 4 to 8. It becomes 4 to 16. It becomes this value squared, my scale factor squared. Okay. Volume factor, it's basically the same idea as the area factor, but because volume affects the 3 numbers instead of just 2, it is now scale factor cubed, because we go from a length scale factor to a area factor, which is squared because it's got a length and a width. Now we're going to deal with volume, which is another dimension, a third dimension to make a cube. Okay, so that's why it becomes cubed value larger, okay? Because I have 3 dimensions now instead of just having 1, okay? So I affect the length, I affect the width, and I affect the depth, or the height is what people call it, okay? So if I had a square that was a cube that was had lengths of 2, 2, and 2, it had the volume of 8 inches. If I doubled everything, if I doubled the length, the width, and the height to 444, if I doubled everything, you would think this would double, but no, it becomes, well, if I did 8 times 8, I'd get 64. So to get from 8 to 64, what we did here is we did our scale factor. We had a scale factor of 2. So I had the original 8 times my scale factor of 2 cubed. And that's where I got 64 from. So this is my original volume times scale factor cubed equals my new scale factor. The same worked over here where I had the original area of 4 times my scale factor squared, and I got my new area, which was 16. Okay. Now if I increased from 3 to 9, these numbers would change because this would be a 3 squared. So that's where these numbers come from. We're going to fill out this activity here um, based off of something in your textbook talking about composition or decomposition boxes, compost containers. Okay, so your textbook is here. Okay, I will post all the notes online so you can copy them down. I do recommend that you listen to the video. I'm not going to post all of the notes by themselves without the video because I think it is important that you listen to how it's described and how it's explained other than just writing it down. Okay, so in our textbook it says, finding enough landfill space for garbage is becoming a problem for many communities. Some communities are considering composting as a way to recycle garbage into productive soil. Composting is a method for turning organic waste into rich soil. Today, many people have compost boxes that break down kitchen waste quickly and with little odor. The secret is in the worms. The Science Club wants to promote environmental awareness in the community. It organizes a campaign to have families build and use compost containers called 123 boxes. They start off with a rectangular wood box that is 1 foot high, 2 feet wide, and 3 feet long. This is a 123 box. Mix 10 pounds of shredded newspaper with 15 quarts of water. Put the mixture in a 123 box. Add a few handfuls of soil. Add about 1,000 worms. Every day, mix collected waste in the soil in the box. The worms will do the rest of the work, turning the waste into new soil. A 123 box will decompose about a half a pound of garbage a day. Okay, now the only thing that we're going to change about this is our box will have a lid instead of being open like it is over here. Okay, that way our surface area will be a little bit clearer. Okay, so we're going to fill out this chart based on the box. It's not going to be an open box, it's going to be a closed box. Okay, and what we're going to do is we're not going to build the model, but we will assume that the number of worms will increase to match the increased volume of the box. So we're going to increase our box from a 123 to a 246. How did these numbers change? We're going to fill that in here. We're going to calculate the surface area. We'll plug it in here. And the volume on these numbers here. We'll plug everything in, and we can see the connection. This is our volume. This is our surface area. And we should be able to find the connection between the worms and the amount of garbage. Okay. Your homework will be posted online as well. Your homework will look like this. It'll be additional practice. 2 pages. This should be on your collection on the way in. You'll also it's talking about dimensions of a box and boxes increasing in size. A little bit of practice on some finding areas of different shapes. Okay. All right, copy down your notes, and we'll work on this activity here based off of this lab sheet.